So I'm Sam, a rising senior at Urban High School, and this is my main project. My starter project is at my house, but what it is the starter project is a miniature Pov display, which stands for persistence of vision. So it will, when you move it back and forth, display a message with an array of LEDs. So it displays slices of vertical slices of an image or a line of text, and then when you move it really quickly, then your brain will combine those different slices into one message. And I completed that in the first few days, and then moved on to working on this box here, which is a box with a musical lock, which means that it will open when you play the right tune. And the original project, I found the idea for it online, although the documentation provided by the original creator was not complete and listed several components that either don't work or don't exist anymore. So I had to figure out basically entirely how to make this on my own, save for a few things that did carry over from the original project. So the basis for the control system is an 80 mega microcontroller, and eventually that will be powered by a battery, but right now the power is coming from this adapter. And once I got the 80 mega controller and all the components that I figured out I needed, then the first step in creating this was to figure out how to detect one specific frequency, which is the first step in learning how to detect a whole melody. So to get that working, I used an algorithm called a Goertzel algorithm, or a Goertzel filter, which is basically, it's a way to efficiently compute one component of a discrete Fourier transform, which is, for those of you who don't know what a Fourier transform is, that's the magnitude of a specific frequency within an audio signal. So that could be like a concert A, which is 440 hertz. And I tested that with the function generator that we have here. So I ran, instead of a microphone input, the output from the function generator into my 80 mega with a Goertzel filter running to see whether it could detect a certain frequency. And originally I had the sampling rate set too low on the 80 mega, so it wasn't able to detect the frequency because I was looking for a frequency that was above the maximum allowable frequency with the particular sampling rate I had. So I changed that, and eventually I was able to get it to detect several frequencies in a row from the function generator. So then I decided it was ready to connect to a microphone, and I originally had a specific microphone that's made to work with Arduino or with an 80 mega controller, but I broke that by connecting the negative voltage to the positive and the positive to the negative. So I ended up going with my own microphone circuit, so I got just a microphone by itself and used my own amplifying circuit. And then once the microphone was working, the next step was to connect the servo. So the servo is the motor which controls the lock mechanism, which you can see once I open this up. And whenever I connected the servo originally, just directly to my 80 mega, and whenever I moved the servo, the whole circuit would reset because the servo would draw too much power, and then it would set off the brownout detector on the 80 mega, which is basically just a circuit which monitors the current flowing through the 80 mega, and if it ever drops too low, then it resets the system. So I fixed that by adding a decoupling capacitor, which is just a capacitor to stabilize the current through the whole circuit. And then I had the servo working and the frequency detection working, so then I connected those two systems. And still it didn't work because the key that I was using, the melodic key, was from Close Encounters of the Third Kind. So the notes in that particular melody are too harmonically related, so the overtones were overlapping and it was confusing the system. So I ended up choosing something else. I chose green sleeves instead, and that worked fine. So now the whole system is working, and as you can see, it doesn't open now, but anyway, plug this in. And the timing has to be precise, so it may not work the first time when I try to play the melody, but it should work. So it did. Okay. So, you can see inside. This is the servo that controls the motor, the servo that controls the lock. So I have a hook here, which goes into that loop to keep the box closed. And this is the control circuit, which has the microphone on the side. And then you can't really see what's going on in there, but I have this LED, just for debugging. And there's the decoupling capacitor I mentioned. There's two of them. Whoops. And if you let the lid close, then it relocks, as you can see. As I was building this project, I thought that my main interest would be in programming, because previously I've worked a lot more with programming than with pure electrical engineering, but it ended up being that I enjoyed the microcontroller circuit design just as much as the programming component. So, yeah, are there any questions?
Your inspiration for using melody?
Oh, for my inspiration for
making the music related project?
Well, I play piano, so music is one of the many interests that I have, and when I decided to apply to Blue Stamp, I wanted to do something specifically that mixed circuitry and programming and music, and this turned out to be a really great way to do that.
How close and pitch does the notes need to be?
It has a tolerance of less than a semitone, so if you play the wrong melody, it's not going to work. I mean, if you're say playing on a guitar or playing on it that's slightly distuned, it'll still work. But if you hit the wrong key, it's not going to work. Well,
how precise does the rhythm need to be?
The rhythm, getting the rhythm detection was difficult because the amount of memory that I have and processing power that I have on the 18 mega microcontroller is not enough to really do a very complete analysis of the incoming signal. So I had to let there be a wide tolerance on the rhythm detection. How that works is it records the length of each note as it detects it, which may not be the actual length, but it'll be close enough. And then it'll use a linear regression to scale all of those note lengths into simple ratios. And then if those ratios are within 0.5 of what they're supposed to be, then it'll open the box. So there's a low tolerance percentage-wise for long notes, and a high tolerance for short notes because there's more error relative to the length of the note with the short notes. Yes?
How do you program the key, the melody that you use to open?
Well, in the program I have an array of different floating point numbers which represent various frequencies, and they're in the order of the notes in the melody.
So you can't just record it and have it?
No, I could create a function that would learn a new key, but it requires more processing power than I have on that current circuit.
How applicable the system is to other lock and turn on and off system? For example, can you use a voice activation to drive your car, open your door?
You could use it to open the door. I wouldn't recommend trying to use it on a car lock. It may not be that secure. But I mean, you could, it's a motor, you could put in any motor there, could turn any lock. And if you had a better microcontroller, and I went through a few more design iterations, I could make the tolerance much lower, so it has to be very specific. So it could be, reasonable security for something that, it's not going to be like a car or your front door. Is that it?
Thank you.